Hey there, and welcome. Today, we're going to talk about a math superpower that you probably use all the time without even knowing you're doing it. Let's get right into it. So, first things first, just take a look at this problem. How would your brain tackle it instinctively? Would you add the 2 and the 3 first, or maybe jump to the 3 and the 4? Just think for a second about what feels easiest for you. Well, however you decided to group those numbers, that little mental shortcut you just took, it actually has a name. A formal name in mathematics. We're about to give a name to an instinct you already have. And that name is the associative property. It sounds kind of fancy, but it's a really simple and honestly powerful idea. It just means that when you're adding a bunch of numbers or multiplying them, it doesn't matter how you group them. The final answer is going to be the same no matter what. To boil it down even further, our source material puts it perfectly. It just doesn't matter how you associate the numbers. The result is totally locked in.
You know, I love this analogy. Think about baking bread for a second. Does it matter if you mix the flour and water together first and then add the yeast? Or if you mix the water and yeast and then add the flour? Nope. Either way, you get the same dough. The way you group your ingredients doesn't change the final product.
Okay, so the baking analogy is great, but let's make this really concrete. Let's look at some actual numbers and see how this property really works in practice.
All right, let's go back to that first problem. Imagine these are piles of stones. In the first group, you combine the 2 stones and 3 stones to get 5. Then you add the last 4. But in the second group, you start at the other end. You combine the 3 and 4 first. So, what do we end up with? 9. See? Both roads lead to the exact same place. You end up with 9 stones no matter which piles you decide to combine first. The path is different, but the destination is identical.
Okay, so it works for addition, but does this superpower hold up for multiplication? Let's find out, using the exact same numbers. On the left, we'll do 2 times 3 first, which is 6, and then times 4. On the right, we'll group the 3 and 4 first, get 12, and then multiply by 2.
And there you have it, 24. It's perfect proof that the associative property isn't just an addition thing. It works just as well for multiplication. It's a solid, reliable rule you can always lean on. Now, this is all great with specific numbers, but the real magic of math is finding rules that work for any number. So let's level up from simple arithmetic and see what this looks like in the universal language of algebra. In algebra, we use letters as placeholders for any number you can imagine. So the official rule for addition looks like this. It's saying that whether you add x and y first or y and z first, it doesn't matter. The equation stays perfectly balanced.
And no surprise here, the exact same logic applies to multiplication. This isn't some neat trick, it's a fundamental law of how numbers work, and this is how we write it in the language of math.
Okay, for this last section, we're going to zoom out a bit. We're going to see how our source material connects this simple, logical math rule to a much broader idea about solving problems in general. But first, a quick challenge for you, and this is pulled right from the source's homework problems. How would you prove this expression is equivalent using the associative property? Just take a second and think it through.
So here's how you do it. First, you just solve it the way it's written. 3 times 2 is 6, times 4 is 24. Easy enough. Then you just regroup it. Do the 2 times 4 first, which is 8, then multiply by 3. You also get 24. And boom, you've just proven they're equivalent.
Okay, now this is where things get really interesting. Our source material, which, remember, is a math lesson, includes this very specific quote from the book of James. What the source is doing here is drawing a parallel. The idea is that just like math has these reliable rules to help us solve problems, the source suggests there's a broader principle for life's problems, seeking guidance or wisdom when you're stuck, whether the problem involves numbers or not. And that kind of leaves us with a really cool final thought to chew on. We've seen how the associative property is this sort of hidden rule that helps us make sense of things. So, what other hidden math rules or logical patterns might be guiding your life without you even realizing it? Something to think about. Thanks for tuning in.